Welcome to World Talk Brief. Astronomers have discovered a world that, well, it simply shouldn't exist. It's a planet so strange, it literally breaks all the rules we thought we knew about how worlds are formed, forcing us to rethink pretty much everything.
The planet's name is L9859d. It's about 35 light years away from us, and some recent observations from the James Webb Space Telescope have sent scientists scrambling. Why? Because this is a world that just completely defies our expectations and refuses to fit neatly into any box we have.
You see, when astronomers find a planet around this size, they generally have two main categories, two boxes they can put it in. But L9859d, it stubbornly refuses to go in either one, creating this really fascinating puzzle for scientists. So, what are those two boxes? On one hand, it could be what we call a gas dwarf. That's basically a rocky planet with a really thick, hydrogen-heavy atmosphere. On the other hand, it could be a water world, a planet covered in deep oceans, maybe even frozen ones. But the data that came back from the Webb telescope was crystal clear. L9859d is neither of these. It's something else entirely. So what exactly did the telescope see that was so baffling? Let's break down the clues that make up this scientific riddle, piece by piece. First up, its size. At 1.6 times the radius of our Earth, it's firmly in the Super-Earth category. Now, based on size alone, you'd probably expect it to be a dense, rocky world, right? But its other properties, well, they tell a much, much stranger story. Next, let's talk about its density. It's incredibly low, just 2.2 grams per cubic centimeter. To put that in perspective, that's less than half of Earth's density. This was a major red flag. A planet this large really ought to be much denser, unless it's made up of a whole lot of lighter stuff like gases and other volatile elements. And here's the final clue, and maybe the weirdest one of all. Its atmosphere is just choked with sulfur compounds, like hydrogen sulfide. Yep, that's the gas that smells like rotten eggs, and sulfur dioxide. This chemical signature is just highly unusual and doesn't match our models for a gas dwarf or a water world. So with all these conflicting clues, a super-Earth size, a strangely low density, and this bizarre sulfur atmosphere, researchers realized the answer couldn't be on the surface. They had to use some really advanced simulations to look deep inside the planet itself. And the solution to this whole puzzle wasn't on the planet's surface at all. It was hidden deep within. The simulations revealed that L9859d contains a massive, persistent magma ocean, a globe-spanning sea of molten rock that has existed for billions of years. And this one single hidden feature explains everything. This finding is a real game changer. As the lead author, Dr. Harrison Nichols of the University of Oxford, stated, it suggests our fundamental categories for small planets may just be too simple. Think about that. This single world is challenging the very way we classify planets. So how does a hidden ocean of lava solve both mysteries at once? Well, it all comes down to a really dynamic cycle happening between the planet's deep interior and its atmosphere. Okay, so think of the magma ocean as this huge reservoir that's storing massive amounts of sulfur. This sulfur is slowly released into the atmosphere as hydrogen sulfide. Then, high up, intense ultraviolet radiation from its star zaps some of that gas, creating sulfur dioxide. And here's the crucial part. This magma ocean acts as a buffer, constantly replenishing the atmosphere and stopping it from being stripped away into space. This sustained outgassing is what keeps the atmosphere thick, and that perfectly explains the planet's surprisingly low density. Looking back at its nearly 5 billion-year history, the planet wasn't always like this. The models show it probably started its life as a sub-Neptune. That's a world bigger than Earth, but smaller than Neptune, with a thick, gassy atmosphere. Then, over its first 1.5 billion years, it cooled and contracted, losing some of that initial atmosphere. And ever since, it has stabilized into its current state, a super-Earth with its atmosphere perpetually sustained by that hidden magma ocean. This also means if we had seen this planet earlier in its life, we would have classified it as something else entirely. So what does this all mean for our search for planets across the galaxy? It means we've just found a brand new recipe for how to build a world. The discovery of L98-59d is so important for a few key reasons. First, it reveals an entirely new type of planet, which challenges our neat little classification boxes. It also shows that magma oceans, which we think existed on the early Earth, can be stable enough to actually sustain an atmosphere over geological time. And that offers us a fascinating window into the early history of rocky planets, including our very own. The universe is clearly far more creative than we ever imagined. The discovery of this strange, molten sulfur world just proves that when it comes to planets, we've only just scratched the surface. And it leaves us with one profound question. What other types of worlds are out there, just waiting to be uncovered? Subscribe to World Talk Brief for more clear, thoughtful explanations.